When we think about exercise, we picture muscles straining, weights clanging, and sweat dripping. But deep within our cells, there's a universe of activity happening that's invisible to the eye. A recent study by Edman, 2024, takes us on a molecular journey, revealing how a single molecule called MYC acts like the conductor of muscle growth after exercise. Buckle up as we dive into this microscopic symphony that shapes our strength and health. Imagine your muscles as bustling factories, churning out the tools and structures needed to support your movement. Exercise acts like an urgent command: upgrade the factory. But upgrades don't happen overnight. They require planning, resources, and skilled managers. Enter MYC, a protein that's not just a manager, it's the visionary architect, orchestrating the entire upgrade process. Now let's break it down. What happens in your muscle factories after a tough workout? Act 1, the alarm bells, 30 minutes post-exercise. Picture this. 30 minutes after lifting weights or running hard, your muscles are in crisis mode. It's like a fire drill, DNA methylation, a process akin to marking up blueprints, starts changing which genes are active. This sets the stage for the real work ahead. At this moment, your muscles aren't growing yet, they're preparing. MYC begins to stir, getting ready to take charge. Act 2, the early surge, 3 to 8 hours post-exercise. This is when the factory hums to life. Workers, ribosomes, are built, and raw materials, proteins, start flowing. MYC steps in as the foreman, guiding which tools are made and how resources are allocated. Think of the stage as the muscles version of expanding production lines and hiring more workers. Act 3, the big build, 8 to 24 hours post-exercise. The final act is where things really take off. Ribosome biogenesis, the creation of the cellular machines that make proteins, becomes the star of the show. MYC is now fully in control, ensuring the factory churns out what's needed for growth and repair. This stage is all about efficiency, making sure the factory runs at full capacity. Health on a molecular level. Muscle health isn't just about aesthetics or athletic performance, it's a cornerstone of longevity. As we age, we lose muscle mass, a condition called sarcopenia. Understanding how MYC drives muscle growth could help develop therapies to combat this and other muscle-wasting conditions. Optimizing recovery. The research also has practical applications for athletes and gym goers. By understanding when your muscles are most active in recovery, you can time protein intake or other recovery strategies for maximum benefit. MYC is a molecular multitasker. Beyond muscles, it influences processes like metabolism, gene expression, and even cellular repair. Its role in muscle growth could be just one chapter in a much larger story about how our bodies adapt and thrive. What makes this study so remarkable is how it bridges the vastness of science, from molecular biology to practical health insights. It's like discovering the Milky Way isn't just a random scattering of stars, but a carefully orchestrated galaxy with gravitational forces guiding its beauty and function. MYC is the equivalent of that gravitational force for muscle growth. Without it, the system would fall apart. The researchers even demonstrated this in mice. When they artificially increased MYC levels, muscles grew. No exercise required. That's right, MYC alone was enough to trigger hypertrophy. It's as if MYC holds the universal key to muscle growth. While this study paints MYC as the hero, it also raises questions. What happens if MYC is overactivated? In other contexts, MYC has been linked to cancer, where cells grow uncontrollably. Finding the balance between harnessing its power and avoiding its risks will be the next frontier. But one thing is clear. MYC is a major player in the story of human health and adaptation. It's not just a molecule. It's a reminder that even at the smallest scales of the universe is full of wonders waiting to be understood.